Hi, sorry for the technical problems. My name is Alastair Smith. I work at Redgate Software in the UK in Cambridge. And I'd like to talk to you about expressive code. So, as Ken Beck likes to say, you'll never know less than you know right now. You learn along the way whilst you're coding, and so you can take advantage of this process to document what you learn along the way by writing your code in such a way as to express that knowledge that you gain. So current you or present you can be kind to future you by documenting your code, going through this process, so that when you come back to it in the future, you still know what the code is trying to do. Why is this important? Well, Sandy Metz has something she calls the inebriation test. And it works a bit like this. You're on call and you're out at a bar. Your pager goes off. There's a problem in production, and the problem is in a bit of code that you haven't written. You've had a few drinks, so you're not completely thinking straight, and you need to fix this problem. You're losing money hand over fist as the problem persists. Could you, in that state, understand what the code does well enough to fix the problem quickly and easily? What sort of properties does the code need to have in order to be easy to change? Anyone?
Easy to read.
Okay, yeah, easy to read.
Expressive.
Okay, what do you mean by expressive?
Yeah, I mean, it should be clear what it does rather than like. So the method name, etc., should be presented. So what problem is it? Easy to find out the intent. Easy to track intent.
Yeah, okay. So yes, the method name should be clear, the other identifiers should be clear, classes, etc. Yes, in fact, you used all of the words that I would use myself. It needs to be readable, it needs to be expressive, it needs to be explicit in its intent. It needs to clearly describe what it's trying to achieve. It needs to be organized in a way that makes sense for the application. For example, something like a Rails application or an ASP.NET MVC application, by default will order itself into controllers, views, and models, which is not actually that useful. All it tells you is that you're using the MVC pack. It doesn't tell you anything about the code itself. So Sarah May sort of picked up on this a couple of days ago. She's got a fantastic Twitter account. I strongly recommend you follow her if you're not already. Because she does these fantastic tweet storms of like 50 tweets in the space of half an hour or something, really digging into a topic in some detail. And I always learn something from her whenever I read one of these. So yeah, do check out her account if you're not already following it. And she said that the inebriation test reminds her that everything in her code should provide information beyond the semantics of what it does. So it should be telling you about why the code exists, what it's there to achieve, and not just the implementation details there. So as we just discussed, the variable names should indicate their intent. The structure should make all of the possible execution paths through the code obvious, and the ones that are most likely to be followed should be blindingly obvious. To switch tracks slightly, how many of you have read a EULA recently, an end-user license agreement? No one. What about the EULAs for your own products? If you haven't read one recently, clearly you haven't read one of those. Why not? Yep, too long, too complicated to understand. This is the end EULA from our products. The EULA from our products, and it's just one part of it, about the evaluation period. In English, we talk about legalese, the language that is peculiar to lawyers. It's as far as sort of legal language goes, this is comparatively readable, but it's not something you'd actually want to sit down and read. It's not something you'd actively look for. The purpose of legalese is to remove ambiguity. And as a result, it can deteriorate into pomposity, sub-clauses, sub-sub-clauses, and worse. the removal of ambiguity seems to come at the expense of clarity and comprehension in this case. And I think code like this is similar. You probably can't read it even. That is one method of about 50 lines of code. And it describes how to go about connecting to a database in the product that I'm currently working on. The reason that I put this up here is because programming languages are also communication tools. And the clue is in the word language. As my first year university lecturer told me, the purpose of a bit of code is to describe to another developer what you're trying to achieve. It's not to tell the computer what to do. It's how you communicate between developers. And to my mind, imperative and procedural code like this, with deeply nested if statements and for loops and all the rest of it, is our equivalent of legalese. It's focused on the implementation details, on how to get the job done, and not what the programmer is trying to achieve. Nested ifs are like the subclauses in legalese, and the abstract factory proxy builder bean type class names are but one example of pomposity in software engineering. Steve McConnell in Code Complete. How many of you have read Code Complete? A couple of hands going up. Cool. He likes to say program in the problem domain, not the solution domain, because that's where the expressiveness lies. The problem domain is the thing that you're trying to solve. It's the concerns that you're looking to address. And the solution is all about how you're doing this, not what you're trying to do. Expressiveness comes from the problem domain, the what rather than the how. So applying Sandy's inebriation test to this code, I would ask you if you'd spotted the bug, but I can't read it from here, so I bet you can't read it from there. There is a bug somewhere near the top. Let's see if that makes it clearer. Yes, in that area there. What that bit of code is doing is passing the output from a command line program to determine whether there is whether the version of SQL Server that we're connecting to is a local DB instance, an in-memory instance, rather than a fully hosted one. And the bug that we had in that was that it fails on any version of Windows that is not running Windows, because the command line output from this program is not in English. And the middle line that's highlighted there says, if the string output contains the word state, then carry on and do something. We can't do that on non-English platforms. It's too focused on specific implementation details. So how can we get away from this and into more expressive code? I like to use the 4 rules of simple design in coding. And where these came about from was T.A.K.E. And in the foreword to Corey Haines' book, The Understanding the 4 Rules of Simple Design, he described about how they came about. And he said, I thought about how I recognize simplicity. I turned those criteria into actions and sorted them by priority. It's no coincidence that human communication is number 2. There are many formulations of the 4 rules of simple design, and this is the simplest one that I've come across, and it comes from Corey's book. So the first rule is that all of the tests pass. It's functionally correct. The second rule is that it expresses its intent. The third rule is that there is no duplication. It doesn't repeat itself. And finally, it's small. There is no extra code there that doesn't need to be, doesn't have a reason for existing. So let's dig into these in a bit more detail. The tests passing. There's nothing here about them being automated tests. This is about correctness and verification. It's not about having a specific test suite. Having said that, the length of time that it takes to make sure that your tests pass can be a significant factor in making changes. So if you have to ask how fast your test suite should be, it should probably be faster. Expressing intent. It's easy for the names that we give to our types and members to stray from the abstractions that they represent. And one of the most important qualities of a code base is how quickly you can find the part that should be changed. So repeating the example of Rails and ASP.NET MVC and similar frameworks, if you can't find the thing that you're looking for easily, quickly, then you're going to struggle to make a change to it in the first place. And the difficulty in finding an expressive name for something is a red flag that it is doing too much and should be refactored. No duplication. Every piece of knowledge that we have in our system should have one and only one representation. And this is explicitly about knowledge duplication. There's a common misconception that the dry principle applies to code. And it can often be that the code does look very, very similar, but is actually there for different reasons. It's encapsulating different pieces of knowledge. So don't necessarily look for explicit code duplication. Ask yourself whether or not the duplication you see is an example of core or domain knowledge in the system. And finally, small. Sometimes we build things that aren't used in the final product. Remove them. Do I have any duplicate abstractions in my code base? Quite a few refactorings will create abstractions, such as extract method, extract class, etc. If you find that you've got more than one abstraction doing the same thing, just combine them. And sometimes we can extract too far. So, for example, extracting a method to improve readability while cleaning up our code can sometimes be a step too far for the end result if that method is just one line of code, for example. We can simply inline those methods when we're done. The nice thing about these rules is that they're actually somewhat iterative in nature. Fixing a naming issue can reveal duplication. Fixing duplication may uncover potential improvements for expressiveness. J.B. Rainsberger likes to say that every good design principle you've ever heard of reduces to some combination of remove duplication and improve names. Ultimately, we're at the mercy of the implementer's rule, which simply states that implementer's rule. Whatever code you've got is there because it's the way it was written. How many times have we been the victim of things like merge bombs or prototype code or we need to ship this now, just get it out the door? If we can use these rules to get the implementation right the first time, then our implementation really can rule. So, I mentioned this book a couple of times already. The advice that I'm going to be providing shortly is based on my reading of this book. You should read it too, for so many reasons. There's some fantastic advice in there. It's all based on Corey Haines' experiences going around code retreats, facilitating them, observing participants. And the code retreat format is a really good format for learning and developing your test-driven development skills, your 4 rules of simple design skills, etc., etc. You get to pair with different people throughout the day and just get to practice in a kind of safe environment, all the things that we strive to do on a day-to-day basis. There's a global day of code retreat every year. I think it's in October this year. So keep an eye out for news of that and yeah, sign up if there's one running near you. So I'd like to start with a couple of ideas for ways of improving your tests. The first one being that your test name should influence your API design, and the second one that we can use our tests to root out subtle duplication. So influencing API design. Tests are a form of documentation for our code. It's an executable specification. Our tests must be just as expressive as our production code. Assuming TDD or even test first, your test names can then influence your API design. The test names and the intent of the test code should match 100%. If your test name mentions a concept, then the test implementation must refer to that concept too. Don't leave it implied. Take a moment to check you're actually testing what you say you're testing. In the first test here, we state a new carriage must be empty, but the verification is checking a collection of passengers. In the second test, we're checking for some number of assigned seats, rather than the seat we assigned was actually assigned. Here we are violating both the law of Demeter, or 1 dot per line, and commands query separation, or tell don't ask. Refactoring these tests to express their intent, the second rule of the 4, leads us to fix these violations. We now tell the carriage to calculate the information we want, and we are only using 1 dot per line. This has also led us to spot a third test, which was previously missing, and that is that assigning a seat to the carriage means it is no longer empty. Rooting out subtle duplication. The previous test includes some subtle duplication of knowledge, the representation of a seat in a carriage. The result of the duplication is one of the classic code smells, its primitive obsession. As well as duplication, the test exhibits a naming problem. We're not effectively expressing the intent of assigning a seat. We fix this with something called reification, which is the act of making something real. And we achieve this through extraction. We extract the number in our test to create a seat abstraction. A couple of ways that we can improve our objects then. We can look for ways to avoid procedural polymorphism, and we can invert our composition of objects to break inheritance. So procedural polymorphism looks a bit like this. In this method, why do we so explicitly care about the state empty? What happens if we add another state, such as full? Why not highlight that state instead? Empty is just a flag, after all, and we're using it to change the behavior of is accepting reservations. So the point of polymorphism is being able to change the behavior, or receive different behavior based on one method call. And in this case, we are achieving that aim by using an if statement. But in object-oriented languages, such as C#, as we've got up here, we can use inheritance to achieve the same thing. As so. So we have a carriage class which has some default behavior, and we have an explicit empty carriage that includes the overridden behavior. If you haven't come across the anti-if campaign, then check it out afterwards. It's quite fun. It's sort of a bit of a jokey thing, but it's got a very kind of real message underneath it as well. It's all about using the features of your language, the object-oriented classes in an object-oriented language, functions in a functional language, to achieve the same thing but in a more expressive way than all of the deeply nested ifs that we see. And inverting composition. We can start off with, say, two types of carriage, a standard carriage and a first-class carriage. And we can look at this and see, okay, well, our carriage has a seat. And probably it has many seats, otherwise it's not a very useful carriage, but you can read many for one in this example. We see it as having, we see as we have different types of carriages that we have duplication. All carriages have seats. So we extract a base class to remove the duplication. That's the job done, right? Not so much. We still have duplication there. It's just more hidden now than it was before. And all future carriages that we add will also have seats. What if we want to introduce a standing-only carriage, for example? Well, we can replace that base class with an interface instead, right? And that is the job done, surely. Again, very close, but not quite. Using interfaces in this way can help find hidden dependencies in your application, and it can highlight the different responsibilities that a class has. But it's not the end goal. How can we eliminate this duplication? Well, what is our end goal here? Our end goal is simply to have a link between the carriage and the seat. We can achieve that by just reversing the relationship so that the seat now has a carriage. This still makes sense in our domain because seats do belong to a carriage. And it's also simplified the collection management concerns that I completely glossed over in the first place. It's also a nice illustration of the dependency inversion principle in action at the micro level. We're all familiar with inversion of control at the macro level, but rarely in my experience has it been applied on the micro level too. This simply states, the principle simply states that concretions depend upon abstractions. So the concretion of the seat, the actual thing that the implementation detail, The dependency there is now inverted to the abstraction of the carriage. Another quote from Sandy Metz: "Don't write code that guesses the future. Arrange code so that you can adapt to the future when it arrives." This is real planning for the future. You don't know what the future is going to bring, and it never brings what you expect it to bring. Code for all possible futures, including the one where you have to fix a production problem drunk, not just the ones that you can foresee. I started by saying that you'll never know less than you know right now. Hopefully, you now know a little bit more than you did when I started. Thank you very much.